Welcome to a new test and teardown video. This time it's a receiver. The model is SPM 12 from Wandel und Goltermann. Selektiver Pegelmesser. So it's a receiver covering from 200 Hertz to 4.5 megahertz. We got an in connector for 4.5 megahertz. Really different inputs, balanced inputs, I would assume, with different impedances and all that. We can also have a high impedance mode. We got the demodulated output and the signal level, where you can manually select the gain. The bandwidth is also configurable, and I bet this is the frequency readout. And I can't move half of these. Those I can. This I can't move. This one I can't move. This one I cannot move. The frequency adjustment, you pull or push, that's pretty sexy. I think this one was left outside in the rain, so I don't expect to be able to power it up or anything. And you can even see it's quite dirty as well. I don't really plan to clean it or anything. I just want to open and see what is the status. It is really, really big. If you look here in my little workshop, you can probably imagine. It's a really nice handle. It's also very, very heavy. And here at the rear side, we see 3 more end connectors. They are a little bit special, those end connectors. What exactly is going on? Normal IEC power. Oh, we can power this from an external battery all the way from 12 to 60. How about that? I wanted to start my little inside adventure at the bottom, because here is a lot of really cool things. Look how everything is inside little individual shielded boxes. I really love this design style. We got some tape. It looks like nobody was ever in here. Look at that. And I hope you can read a little bit German, because everything here is of course written only in German. So this is the input, and this is the front end amplifier, and this is a broadband amplifier, and that will be a bandpass filters and the mixers and all that. But I will just open everything, and then we can enjoy the fantastic design. This looks so beautiful. I can't move those 2 potentiometers. I want to try and see if I can put some of my cleaning fluid in here and just see if that is possible to do magic in a completely stuck potentiometer. Let's look a little bit inside all those fantastic boxes. So of course this is the input selector and all the impedance and balance and all that kind of stuff. And there we go to the first input pre-selector and the amplifier. And here is another amplifier. It's just so beautiful. And of course we got some relays for remote controlling of the amplifiers and settings. Let's just look at that track that goes here from the amplifier to the filters. That track is hidden beneath this shield. All those boxes, they're made of plastic, chromed plastic. So this is good to keep the weight a little bit down. Then we got a mixer. And we got a little bit of match for the filter sections. So that is 8 megahertz. So it mixes everything to 8 megahertz. And then there's another mixer. And the input to that mixer is almost 8 megahertz. See, 800 or 8010, I think it's just below. And this one is from 1975. And since a TCXO like this would be very expensive, I bet this date on this one is very close to the age of this unit, because you don't buy a lot of these and stock them, right? You buy them like running in production, so it's probably close to the age. There'll be some selectors for the different filters. Of course, we are transistors and diodes and all that, selecting everything. I put in a little bit of contact, 61, and as always, super magic, easy. Now, everything is moving quite nice. So that will be mains switch, obviously in a little shielded cable, inside a little protective box. Well done! Let's look a little bit from the side. See, that was the bottom. There's another layer of boxes inside, and then there's a little hinge here. So I think the idea is we can loosen some screws somehow and then flip the entire front up, and this way access something somehow. Or maybe the idea is that this part here is the one that is flipped. I don't understand yet. I'm going to figure that out. Here is the top. Why are we having high voltage in here? That is a little bit why, but I think it's because in here we probably got the read out control. Or is it in here? Because you can see this is the readout, and I believe that will be the Beckman displays. They're running on 100 volts or something like that. But it goes in here, right? Somebody dropped. This one is 70 volts. So the readout goes, of course, to the PLL counting driving display stuff. So you got all the counters, latches and drivers for all that. And here to the left, if we only care to read a little bit, here we got some input filters, and this is a switch mode converter, and that will be all the output filters for the different voltages. So it's 180 volts for the display system. And in here we can see, I bet that is the little transformer, and here is the power part of the regulator. And we got all the nice little filters in little individual rooms. Really good design. And here is the brain of the power converter. What? It is very corroded on the screws and all that. Probably got some lead capacitors here causing this to happen, right? Also, the top metal here on those inductors, see how corroded everything is. Beautiful. The connectors here, huh? Look at that. I was able to figure it out quite easy. Just 2 screws here at the end, and then flippity floppity open. And of course also this screw in the hinge. But look at that. This one and that one. So I believe what we can do is flip this to this point and then put the screw back in here. And then it will be fixed open, and then we can access everything in a nice and good stable way. I kind of like that. They thought about everything. I'll try and see if I can open this a little bit more and make a little bit of video of the different boxes and what we got. I also really want to go inside here and have a little look. I was able to flip it all the way up, and now we can have a little look at the other boxes in here. I will of course open them in a second. Yeah, I think the mains transformer is in here, right? So this is where we find input filter, frequency counter, right? So I opened all the little boxes here for us to enjoy the nice view. And of course we can see what kind of quality level everything is made to. Different amplifiers, different filters. Everything here is done for about 10 kilohertz. That is the intermediate frequency of detection and all that kind of stuff. And look at that box. Is that a crystal filter or a resonator filter or something like that? If we read up here, maybe we can see. So this is a little bit under, and the other one is exactly 10 kilohertz. That is something I've never seen before. This size is also like really nice. And it's so the yellow wire is a shield of some sort. And then the entire chassis around these, that will be shielded. How beautiful is that? And then here is a low frequency filters as well. And again, this box is made of steel that corrode. And look at that. All the corrosion here is like really bad. And those specially wounded inductors. And look at the capacitors. 0.5% tolerance on the different values here of film capacitors. That is also a little bit impressive. And up here is the frequency counter. It's quite funny how signal just goes in and then we taste a little bit and then it goes on again. A little bit of common mode rejection on the shield. Interesting. And by the way, this type of connector is a little bit interesting. It looks like an SMA, but almost 1.5 times as big. Really weird. And Teflon feed throughs. Those are actually very expensive as well. That will be the DC input capacitor for the external, I guess. And I don't know if I want to go inside this one. I still got one little box to look into. And then there is this frequency adjustment, and I think I want to look at that as well before I pack this beautiful unit back together. Let's start by this super shocking image. I mean, those two switches, I've never seen any. Of course, they can't move. Look at the corrosion. What the heck happened here? They turned self-aware. That is some funny thing. This is a Demodulator, by the way. And that IC is from 1976. So that is the highest number I was able to find so far. Ooh, look at that. That's an early version of the Elma switches, but this is an open type. But definitely this is Elma. This is made in Switzerland, right? And the frequency adjustment, I took off the little top here. So there's probably a little oscillator somewhere. Or maybe that is just under it. But this is how it works. And I can pull it and then it goes super. Ooh, you need to turn it a million times. And then you plug it and then it goes fast. How nice is all that? Yeah, I think actually we have been through all the different things in this unit. There is nothing left to show and tell, by the way. So I think I will call it a day. And I hope you had a little bit of fun so far and could really enjoy this 1975 receiver made at ultra tip top quality level. No doubt about it. Hope to see you soon. Bye bye.